Hello. I wanted to give you a quick summary or reminder or refresher about how we use the cos diagram and how we relate it to trigonometry. So here's the cos diagram, and what I want to highlight is that if you look at the angles, you can see green is the angles moving in the anti-clockwise direction, and these are positive angles. So I start at 0 degrees, move to 90, 180, 270, and I come back to 360, which is a revolution. And I can see that between 0 and 90, all of my trig ratios are positive. Between 90 and 180, sine is positive. Between 180 and 270, tan is positive. Between 270 and 360, cos is positive. Now, that's moving in the positive direction, but if I start to move in the negative direction, I then start at 0 degrees, so you'll notice that the 0 degrees are the same, but now I move in the negative direction. So I'll notice that my first one is minus 90, then minus 180, minus 270, and minus 360, and that also completes a revolution. Now you'll notice as I go into the negative, then I'll have between 0 and minus 90, cos is positive, minus 90 to minus 180, tan is positive, minus 180 to minus 270, sine is positive, and between minus 270 and minus 360, all are positive. Now, if you can remember this is going to help you a lot in reduction of angles, but I just want to show you another thing as well, that if I have a reference angle, or if I'm in the second quadrant, this corresponds to 180 minus a reference angle. If I have the third quadrant, that's 180 plus the reference angle, and if I'm in the fourth quadrant, that's 360 minus the reference angle. Now, what I've done is I've listed 3 examples here. So let us start with sine 180 minus x. Now, if I want to reduce this, how would I do it? So what I do is I start and I look at the reference angle, or I look at the angle that I've been given. Now I've been given 180, so here's 180 here, so I'm going to be starting here, and then I say, okay, negative x, meaning negative means I'm going to be moving in the negative direction, or the clockwise direction. So where does it take me? If I start at 180 and I move in the negative direction, it brings me into this quadrant, and I know that sine is positive in this quadrant. So what I can do is I can then, let me just write this down. Okay, let's use black. So what I can do is I know that this is going to simplify to be sine of x, because that brings me into the second quadrant, and the second quadrant I know sine is positive, so that's how it reduces. Now if I look at cos minus x, right, if I think about cos minus x, I could write it as the cos, I could say 0 minus x, and that's essentially the same thing. But why I'm showing you this, or why I'm writing this like this, is I'm highlighting the reference angle. So the reference angle here is 0. And then minus x is moving in the negative direction. So that means minus x puts me into this quadrant, and I know cos is positive in this quadrant. So I know that this simplifies to be let me write my pen there. This simplifies to be the cos of x. And then lastly, if I look at this one here, cos x minus 180, I use the same concept. So where is my reference angle? It's minus 180. So here's minus 180 here. So I'm starting here. And then x is positive, which means I'm moving in the positive direction. And you'll notice that it brings me into this third quadrant, and I know cos is negative in this third quadrant, so I know that I can simplify this as equals negative cos of x. So now you see how I can use this to simplify my functions and relate them back to the first quadrant. And now, just to demonstrate these reference angles here, let's say I had, as an example, what if I had the cos of 135? Okay, what is that going to simplify for? Now, if I look at the angle 135, I know 135 is in the second quadrant, right? So I know cos is negative, so that's going to be my first thing. That's going to be a negative cos. But I also know that I'm going to do 180. This is going to be my reference angle. So it's going to be 180 minus 135, which is going to be 45. And of course we know that this is a special angle, and all you'll do is you'll convert this into that value for the special angle of 45, and that's how you would reduce if you're given a number like this. So it's just a matter of looking at the reference angle and seeing in which quadrant the reference angle is in, and then reducing in that way. And that's how you would use the cos diagram for all of these reductions. And the cos diagram can also be used to determine or actually construct the sine, cosine, and tangent graphs, and that will be shown in a later video. And I hope this helps you use this diagram for your trig reduction. Thank you, and goodbye.